In synthetic resin method, X, again students, is an example of fill in the blank. So I would actually read it as dash, which would make more sense. So in synthetic resin method, dash resins contain large organic molecules with sulfonic acid, that is SO3H group, and are water insoluble. Then dash resin RSO3H is changed to RNA by treating it with NaCl. Then the resin exchanges dash ions with Ca2 plus and Mg2 plus ions present in hard water to make it soft water. Hence X, Y and Z refer to. Well students, let's go reverse. One thing is very clear. We are talking about a resin which is exchanging some ion with calcium ions and magnesium ions, resulting into water being converted to soft water from hard water. I'm sure everybody knows soft water is due to presence of Na plus ions or H plus ions or K plus ions, right students? So there could be a possibility where you have a resin. We could have a resin in which on its surface you would have SO3, say Na, SO3 minus and Na plus. And now students, from the water which is coming up, say from this side, which is of containing say hard water. So as it is written in the question, it contains calcium and magnesium ions. So there could be a possibility that the calcium and the magnesium ions are going to be exchanged. They are going to be exchanged for Na plus ions which are coming from the resin. So can I write this as Na plus coming in exchange of calcium or magnesium ions? Well students, such kind of resins which give out Na plus cation and in return they take in the Ca2 plus and the Mg2 plus cation. So don't you think they are exchanging one cation for another cation? So they are termed as cation exchange resins. So actually this is an example of a cation exchange resin. I hope everybody gets this clear, where Na plus is exchanged for Ca2 plus and Mg2 plus. So now students, eventually this hard water would now have only Na plus ions and it would leave. So enters as hard water, leaves as soft water because it would only contain Na plus ions. Students, this resin which was SO3Na was actually formed from, if you could now understand from the question students, this resin which was initially was having the SO3H group, if you could see in the first line. And it was this SO3Na which was actually reacted with NaCl, because if you now see in the second line that this resin is RSO3H which is changed to RNA. So this is my resin Na by treating it with NaCl. So when you treat it with NaCl, it is this H and Cl which was coming out, and Na was taking the place of H and becoming RSO3Na. So now I hope students this is making sense. So now if you ask me to fill in the blank, I would say that this is actually a cation exchange resin which contains large organic molecules with SO3H group and are water insoluble. then it is this exchange resin is changed to RNA. By treating it with NaCl, the resin changes Na plus ions, or rather I should say the resin exchanges Na plus ions with the calcium and the magnesium ions, see here, which results into the hard water being converted to soft water. So don't you think, students, the answer should have been X is cation exchange. Then the exchange resin is changed, and then the Na plus is exchanged with Ca2 plus and Mg2 plus. So hence the reason the answer is option B. You have the cation exchange resin. Then students, you have the ion exchange resin, which is changed to RNA. And then you have the Na plus, which is exchanged with Ca2 plus and Mg2 plus. So the answer to this question would be option B. Thank you.